In this question, we are given the function c of x, which represents the daily cost to produce x high performance wheels. The maximum number of wheels that can be produced on a given day is 100, and we should answer these two questions. That is, in the first part, we determine the production level that gives the lowest average cost per wheel, and in the second part, we should determine the minimum average cost. So let's see how to answer these two questions. Okay, so first let's answer the part one. And here we have to determine the average cost per wheel. So I'm going to write down the formula for average cost. And this is represented by C bar of X. And this equals the cost function over X. So let's determine this average cost. I write down C bar of X. And this equals, I replace C of X as given this function. That is zero point 0 x cube minus 6.0 x squared plus 179x, and this is all over x. Let's simplify this. So this can be written as zero point 0.06. I'm sorry, this is 0.06x, 0.06 x cube. This is over x minus I consider the second term, that is 6.0 x squared over x, plus the last term is 179x, and this over x. Now you can see that we can simplify this powers of x. That is, this goes two times, that is x raised to the power of 2. And we can reduce this power by 1 by subtracting this one. This is 1. So 2 minus 1 is 1. And we can also cancel these two x's. So let's write down. So this becomes 0.06. Here we have x squared minus 6.0. Here we have x plus this is 179. So this is the simplest form of the average cost function. And now to determine the production level that gives the lowest average cost per wheel, we can use the calculus first derivative test to determine the production level which gives the lowest average cost. So for that, I'm going to use the first derivative test. That is, we have to first to find the critical numbers of the average cost function. And we know that according to the first derivative test, critical numbers occurs at the function is 0. That is, the derivative is 0. So we take the derivative of the average cost function, that is c bar prime of x, and set this up equal to 0. And from this, we have to determine the value of x. And we will also use the second derivative test to ensure that only at this production level, the average cost is minimum. So let's do that. So first, I'm going to find the derivative of the average cost function. I write down this as c bar prime of x, and this equals, I should find the derivative of each terms one by one. So the derivative of 0.06 x squared is 0.06, and the derivative of x squared is 2x, minus the derivative of 6.0x is 6.0 is a constant, and the derivative of x is 1, plus this 179 is a constant, so its derivative is 0. So let's put this in a simplified form. So we have the c bar prime of x, which is the first derivative of the average cost function, and this equals, we can multiply this numbers, that is zero point 0.06 times 2, and this gives 0.12x, minus we have 6.0 times 1 is 6.0. So we found this derivative. Now we have to set this up equal to 0 and then determine the corresponding x. So I'm going to set this derivative equal to 0. So I'm going to plug in c bar prime of x equal to 0. And when I do that, I get 0 equals 0.12x minus 6.0. So let's solve for x from this equation. I can add 6 on both sides. So I get 6.0. This equals 0.12x. Now to solve for x, we should divide both sides by this quantity, 0.12. So let's do that. This is 6.0 divided by 0.12, and this equals 50. So here we get only one critical number, that is x equal to 50. And we can see that at this production level, the average cost is minimum. But we have to be sure about it. For this, we can use the second derivative test. So let me find the second derivative of the average cost function. For this, I'm going to use the first derivative. So let me copy that. That is, we have c bar prime of x, and this equals 0.12x minus 6.0, 0.12x minus 6.0. Now let me find the second derivative. So I write down c bar double prime of x, and this equals 0.12. The derivative of x is 1, so it is 0.12 times 1. The derivative of 6.0, which is a constant, is 0. So this equals 0.12 times 1, which equals 0.12. And this is going to be always greater than 0. Also, it is independent of x. So there is no way that we can put this critical number into the second derivative test, as it's already greater than 0. And if this is positive, then according to the second derivative, this is concave upwards. That is, at the critical point, the function gives the minimum value at this point, minimum value or lowest value. So we can clearly see that at x equal to 50, the average cost is minimum. So at x equals 50, the average cost is lowest. And this answers the first question. So this is the production level, that is 50 wheels. This is the production level that gives the lowest average cost. So at x equal to 50. Now let's answer the second question. That is, we should determine the minimum average cost. And we can find this by plugging this production level x equal to 50 into our average cost function. So let's take the average cost function. So here we have the average cost function. This is c bar of x. So I'm going to copy this average cost function, which is c bar of x. Okay, here I have copied this average cost function. Let me plug in x equal to 50 into this average cost function. So therefore this becomes c bar of 50, and this equals 0.06 times 50 square minus 6.0 times 50 plus 179. And we can plug this expression into the calculator to determine its value, and we get 29. So this is the average or the minimum average cost, and this is in dollars. Minimum average cost equals $29.